Hello, my name is Colin Trolligator, and I am a materials engineering major from the class of 2019. We will be working through practice problem number 1 from chapter 4.5 in the general chemistry workbook. You should begin by working on the problem yourself to see if you can get the answer. Pause the video now until you have completed the problem. Then we'll go over it together. Now that you've attempted the problem, let's work through it together to make sure you understand each component involved. First, we should recognize that since we're given the volume of the solution of acids, 100 milliliters, we should look for the amount of moles of each acid to determine their respective concentrations. We can calculate a relationship of the moles of hydrochloric acid and sulfuric acid equaling 0.7 moles as stated in the problem and reserve the total volume of the solution till the end. So for the rest of the problem, I'll be denoting HCl as X, and sulfuric acid, H2SO4, as Y, with the original given equation being X plus Y is equal to 0.7 moles. We should also recognize that equivalence point is a key reference for solving the problem. The equivalence point of a titrated solution marks when the moles of the acid equal the moles of the base. Since we're given the volume and the concentration of the base, 50 milliliters, NaOH over 1,000 milliliters, or 1 liter, we find that at the equivalence point, it's 0.01 moles of acid to base. Therefore, by using the balanced equations of the acids reacting with the base, we can establish each acid's contribution at the equivalence point. So for HCl plus NaOH yielding NaCl plus H2O and H2SO4 plus NaOH to Na2SO4 plus H2O, balancing. We see that for every 1 mole of HCl reacts with 1 mole of NaOH. For every 1 mole of H2SO4 reacts with 2 moles of NaOH, thus creating a new relationship from the variables mentioned earlier of X plus 2Y is equal to 0.1 moles at the equivalence point. Now using this new equation along with our original equation of the acids, we can create a system of equations to find that X, in this case, equals 0.04 moles, and Y is equal to 0.03 moles. Relating these two variables, the X and the Y, back to their original compounds, and dividing both by the 100 milliliters of the acid solution, we find that HCl has a concentration of 0.4 moles per liter. H2SO4 has a concentration 0.3 moles per liter. Hopefully this video has helped improve your assessment of titration problems and has shown you some key skills that are utilized throughout chemistry problem solving.